Content Delivery Network Overview. In this section, let's look at some of the conceptual details of what a content delivery network is and how it works. So what are the objectives? We will begin our section with a brief introduction into the internet performance and scalability. Then we'll talk about the background behind CDN and how they evolved. Then we'll finally define what a CDN is. Then we will look at the CDN architecture at a high level. And then we'll look at some of the benefits that CDN provide for applications. And then we'll see how web applications can actually use CDN in order to improve their performance, scalability, and availability. And then finally, we'll look at some of the CDN providers that are there in the marketplace. The internet is changing. The web is changing. It's a changing landscape. When we started the web in the early 1990s, HTML pages did not even have images. Today, images are some of the founding contents on the internet, although there's a lot of text there too. Look at a website like Amazon.com. In Amazon.com, you have so many different images, all the different products that they're selling. If you look at CNN, even in CNN, which is a media publishing site, there is a lot of images. There's even videos in CNN. All the ads appear as images. If you look at sites such as speakerdeck.com, you'll see that they have a lot of PDF documents on their website. And similar thing is true with slideshare.net. If you look at sites like YouTube and Netflix, there's a lot of videos over there. And these videos are actually streaming videos using RTMP, which is real-time messaging protocol. So there's a lot of content that's on the internet. There's lots of content being created on the internet. Visually, I have a chart over here. It's a eye candy chart, which illustrates how much content is being generated per minute. Look at YouTube. Within a minute in YouTube, 48 hours of video is being uploaded, which means every 7 to 10 days, about a century worth of video is being uploaded into YouTube. People are creating brand new websites. 571 websites are being created every minute. Instagram users are sharing close to 3,600 new photographs. When they're sharing these pictures, their friends are going to be getting these pictures. They have to be delivered this particular content. As you can see, there's a lot of content that is being generated on the internet, on the web. So let's look at users, contents, and clients. The users are accessing the content from all over the world. They are accessing it from Japan, they are accessing it from San Francisco, they are accessing it from Doha, Qatar, in the Middle East. Everywhere, people are accessing the content on the World Wide Web. Users are also using a variety of devices. They're using cell phones, smart PDAs, laptops, desktops. All kinds of different kinds of clients are being used to access this content. You can even say even TVs are now being used to access this content. Users are always connected. And what are they really looking for? They're looking for MP3 music, videos, e-docs. They're looking for services, streaming video services, streaming media services, all kinds of content users want from all kinds of places at any time. If you look at the internet dynamics from a networking perspective, with the rapid growth of the internet, these services that are on the internet are really competing for a finite network and computing resources that we have, right? So there's only so many computers and there's only so much network bandwidth we have on the internet. And the reality is that high availability and responsiveness are really key to business websites. If your application is slow in performance, people are not going to come to your page. They're not going to visit your site. Large number of users are trying to simultaneously access the same website. And this happens especially in situations like flash crowd, which is basically, so somebody writes something good about your website in Slashdot, or somebody writes bad about your website in Slashdot, and now suddenly there's a flash crowd that is coming to your site and see what is it that you're offering or what is it that you wrote. So if you look at the internet dynamics, we want high quality, highly available, highly responsive site, but there is only limited finite network and computing resources on the internet. And so a centralized web does not really scale. If you create a web application, if you create a website, and you allow people to access that web application from different parts of the world, from anywhere, it is going to be only slow because the content must traverse multiple backbones and long distances. The way the internet is built, it's pretty complicated. There's all these backbones and tier 1, tier 2, tier 3, level 1, level 2, level 3 networks. Also, it can become unreliable. The delivery may be prevented because there may be congestion or backbone peering problems. Peering is basically when different network providers are communicating with each other, helping each other out and sharing network bandwidth. Such kind of an architecture is really not scalable, especially if millions of people are going to be visiting your site. And when it comes to video, there's inferior streaming quality that the users can experience because of packet loss, congestion, and also narrow pipes. So the point I'm trying to make is serving users all over the world from one site does not really scale. It needs a different solution. And if you think about it, the internet routing is actually complicated. If you haven't ever taken a class on internet routing or TCP/IP routing, you might want to take one of those classes. The reality is it's quite complicated. I just want to show you a ping. This is a ping, which is really a network service that allows you to see how many hops your network packet is taking until it reaches the destination. I'm doing a ping from Austin, Texas, and I want to go to Seattle. Now you would think that it's a straight line, but let's see what happens. Here's the ping from Austin, Texas to Seattle, Washington. It actually took 10 different hops from 1 through 10 right here. Look at all the hops, and it's actually going through these different internet routers and gateways. Let's see where it actually went from. It went from Austin to Dallas to Washington, D.C., Ashburn area, and finally to Seattle, Washington. It actually went through 4 different cities. That's because the internet routing depends upon several factors. Where congestion is, where congestion is not, who's connected to what, all kinds of different factors are taken into consideration. And performance measurement shows that if you look at the globe, if you have to send a packet and the packet has to travel all over the globe and come back to you, if you have a fiber optics network, that would take about 200 milliseconds to go around, which means to go halfway around the world, it's about 100 milliseconds on an average. So something needs to be done about this, especially if you're going to be having web pages where there's a lot of content and there's a lot of content that you're getting from all these different places. The way the web is, it's not going to work. A web application must have tight security. A web application must be highly available. A web application must perform really well. These are 3 characteristics that are really important for a highly successful web application. And any technology that is trying to solve the internet performance problem has to make sure that these 3 fundamental tenets of web applications are met. The point I'm trying to make is there is a problem and this problem needs to be solved. Well, let's talk a little bit more about performance and availability. Let's start with availability. Why does availability matter? If your application is not available, you're going to have a revenue loss, right? If your site shuts down, it's 100% revenue loss. It impacts customer loyalty and also your brand image. So availability is extremely important. Performance is also extremely important because if you have higher performance, you'll have higher page views, you'll have better customer experience, and you'll have higher conversion rates, which means they will actually end up buying the product. Let me explain to you why performance matters. It's all about economics. Let's say you have a website that is generating close to $100,000 a day in revenue. If you have a 1-second delay in your page load time, that means there is 7% loss in conversions, 11% fewer page views will be there, and there will be 16% decrease in customer satisfaction, which means you can lose close to $2.5 million in sales that year. Just a 1-second delay will lead to a downfall of $2.5 million in sales if you're making $100,000 a day. So performance is all about economics. Now let's look at a typical web page. A typical web page is usually dynamic. Let's say that the home page is index.jsp. It's a Java Server Pages based page. But the page itself has dynamic content and static content. Static content like images. Lots of images over here. They're static content, right? There is also unseen static content like JavaScript and CSS. So a page is made up of static content and dynamic content. And developers spend a lot of time tuning the application on the server side. There's a lot of tools and techniques that the developers have learned over time, and they spend a lot of time doing that. There's a great amount of time and money that is spent in improving the backend infrastructure performance. But the reality is that 80% of users' perceived latency actually comes from the front end. If you look at this waterfall graph, it shows you that the backend is spending about 20% of the total time, whereas the most of the time is being spent on the front end, which is about 80%. And if you look at the client view of performance, the first thing that happens when you type in a URL is that it has to do a DNS lookup. So there is some time that is being spent on DNS lookup. And then there is some time that's being spent on the three-way handshake, the TCP/IP handshake. And then finally, it asks for the content. And so this is the time it takes to get the first byte. This actually kind of tells you how busy your server is. And then the content starts coming back. Once this content starts coming back, the browser starts parsing the content. Then as the browser sees these different images and style sheets and JavaScript and API calls, it starts doing the same thing. It does the DNS lookup, does the TCP/IP handshake, does the makes the call to the server, and then starts getting the content. Most of the time is being spent right here. How can we make this better? How can we make it faster? The challenge. Dr. Tim Berners-Lee, who is credited for inventing the World Wide Web in 1999, poses a challenge about internet and content delivery. He says, how can we make this better? Dr. Tom Layton, who was a professor of applied math at MIT at that time, accepts the challenge. And so he begins his work working with his colleagues to create a better way to deliver content over the internet. He works with a graduate student named Daniel M. Lewin. Daniel M. Lewin is the co-founder of Akamai Networks, and he was actually the graduate student of Dr. Tom Layton, who worked with Dr. Tom Layton in order to come up with several ideas which were patented, and you can find those patents right here. And what are these patents? These patents show you how you can deliver content on the internet using something called CDN. Let's take a quick look at this website. Here's the website. As you can see, several patents by Daniel M. Lewin in conjunction with Tom Layton as part of Akamai Technologies. Lots of different patents that's over here that talks about how you can deliver content over a global network of edge servers. All this work by Tom Layton and Daniel Lewin leads to a company called Akamai, which is the first company that provided CDN services to the world. Well, it so happens that in 1997, Layton and Lewin entered the annual MIT contest for a $50,000 prize for a business proposition using the CDN technology. Their proposal was one of the finalists, but they didn't really get selected. But in 1998, they continued on and developed a working prototype, and with the help of Jonathan Seelig, Preetishni Jawan, and Randall Kaplan, established a company being Akamai. So they launched the company in 1999. By 2005, they were making $1.35 billion in sales by simply serving static content on the internet. And the rest is history. So what is CDN? CDN stands for Content Delivery Network. It is also referred to as Content Distribution Network, although This is a much more popular term. Content distribution is part of content delivery, it so happens. It's based on the work done by Akamai founders. It's a solution for internet service degradation. And what's the big idea behind this? Take the content and distribute the content over the globe so that you can keep the content close to the users so that it can be served fast. In other words, rather than keeping the content in one website, in one location, and have the users come to that one location, let's say your website rather than having all the users from all over the world come to Ashburn, Virginia, it would be a good idea to distribute the content to edge sites or edge servers all over the world so the clients can connect to these edge sites and get the content locally. Let's look at the CDN architecture. In CDN, there are several components that make up the CDN architecture. There is the content distribution, there is the request routing, there is the accessing the content, there is the content delivery, there is HTTP cache, and there is accounting. So let's look at these things in detail. Content distribution. The idea here is that you want to take your content and you want to distribute the content to a collection of servers that are spread across the globe. As you can see over here, I have several servers that are spread across the globe. Here's another view. I have several servers that are across the globe. These servers that are across the globe are what we call edge servers. It's not just one server, it's a form of servers that are geographically dispersed. As you can see, I have 2 edge sites in South America, 1 and 2. I have 2 edge sites in the Australian Islands. I have 1, 2, 3, 4, 5 edge sites in the Europe and Asia. But then I also have something called the origin server. The origin server is the origin site where there is the source for the content. And the idea here is that you want to copy the content and keep it close to the end users. So let's take the content and move the content to these edge servers so that the edge servers can serve the content. In this particular case, the content is being moved, in fact copied, from the origin server to an edge server, so when a user accesses the content, they're actually accessing the content from this edge server, because this edge server is closest to this user that is sitting in Spain. Request routing is content served from closest edge to the server. How do you route the user's request to the closest server, to the closest edge server? When a page or a file or a media is requested by a user, it's actually a URL, and that URL has DNS information. So we actually use DNS to identify where the user is, because you can do a DNS lookup of the client IP address, and then you can reroute the user to an edge server that is physically closest to that particular area. In this particular example, I have the origin to be in Midwest, and then I have 3 edge servers in East Coast and 3 edge servers in West Coast. If I have a user that is, let's say, in South Carolina, that user in South Carolina, when he or she tries to access a URL, will communicate with a DNS server which will route them to a net server that's closest to them. So they will end up being routed to a server that is in North Carolina. Versus if there's a person or if there's an internet user that's sitting in Arizona, if they access the same content, they will end up going to an edge server in West Coast. The closest edge server is determined based on several criteria: closest network hops to the end user, latency, and other characteristics. We'll look at this when we start looking at CloudFront, which is a specialized CDN service from AWS. And we'll see how CloudFront does it. Here's another view. You have San Jose, Singapore, and Dublin as 3 edge servers. The origin server could be, let's say, in UK. If a user is coming from Seattle, they may end up going to San Jose. If a user is coming from Denver, they may end up going to San Jose. If a user is coming from Seoul, they may end up going to Singapore. If a user is coming from Berlin, they may end up going to Dublin. If a user is coming from London, they may end up going to Dublin. That's where the edge server is. Notice the user is really not going to the origin server. You don't want the user to go to the origin server. You want them to go to the edge server. Accessing content. So here's how it works. When a client makes a request for a URL, the client is redirected to an edge server, and then the client talks to the edge server and says, I'm looking for this image. The edge server says, hey, I don't have this image because you're asking me for a URL, and that URL is actually the cache key. It is going to look it up in a cache. There's actually a little cache that's sitting over here in the edge server. So it's going to look at the cache and say, is there, let me write the word cache properly here so you can see it. So it's going to try to look at the cache over here and say, do I have this particular content? Well, I don't. So the edge server will end up going to the origin server, get the content, store it in the cache, and then serve the content back to the user. When the second request comes in to the edge server looks at the cache. It says, oh, I have the content, and so it serves from the cache. And that's what I'm explaining right here in this description, which you can read. The idea here is that you have the concept of an origin server, which is where the primary source of data exists. Then there is the edge server, which is serving the content. The edge server has its own cache. The first request comes in. It tries to check to see if it's in the cache. If it's not, it goes to the server, gets the content, puts it in the cache, and then serves it back to the user so that the subsequent request can be served from the cache. In terms of content delivery, the edge servers, which are in edge sites, have a form of web servers. It's not really one edge server that is serving that particular content in Tokyo or in Singapore. It's a form of edge servers that are there in an edge site. And these edge servers will support HTTP and HTTPS because you may want to serve the content over a secure URL. They may also support RTMP service, which is real-time messaging protocol service, so that you can serve the content in real time for streaming purposes. And these edge servers, if you really think about it, are acting as a proxy cache, similar to a browser cache. Cache is extremely important. HTTP defines cache and how cache can be used. It so happens that there are different kinds of caches. You actually have cache within a browser. Your client browser also has a cache. Your web server, in this particular case, let's say doesn't have any cache. It's really serving whatever the content you're asking for it. We are now talking about CDNs. The CDNs are actually intermediaries, and they also have a cache. So if you look at this scenario, we have your browser in your web client, and that browser, rather than talking to the web server directly, is talking through an edge server, which is the intermediary, which is the CDN, which can contain the cache. Well, if it's going to be caching the content, and if the browser is going to be caching the content too, because it has its own cache, then how do we control the cache? Well, it so happens that the HTTP protocol has a lot of cache control headers, like the expires header, the etag header, the cache control header, which has max age and smax age, private and public, no cache and no store. These are all very specialized key value pairs that can be put in order to control the behavior of cache within an edge server and within the browser. If you're going to be using CDN, you need to understand these different caches. When we think about static content, we typically think about images like logo image or JavaScript files or CSS files or an MP4 or resume document or even a static HTML page. That's what we typically consider static. But static actually has a much broader definition. The definition of static in a CDN is really reusable content. A given content is considered to be static if it is reusable for a certain period of time. In other words, if you have a document, and if that document between T0 and T1 does not change, and it changes only at some time T1, during T0 through T1, the document remained the same, that means that content is static. That content is cacheable. That content is reusable. That content can be served again. And that's a much generic definition of what static content means, which actually takes CDNs to the next level, which also means that CDNs can now serve reusable content. For example, if you have content that is being served from a dynamic site, for example, here I'm trying to create an image of a book of a certain size. Well, how often is the image of the book going to change? That means it can be cached. How often is the API for get books going to change when the category is math? These things can be cached, which means these things can be considered to be static content. So the definition of static content also changes when it comes to CDN. And many CDNs actually provide this dynamic content cache. And finally, as part of CDN, there is also the accounting component. As part of the accounting component, the CDN platform providers have to maintain logs of client access, every request that came in, the HTTP headers, the IP addresses, record usage of the servers. What are the different servers that they're using at the edge site? What are the servers that they're using for the origin of content? Also assist in traffic reporting and usage-based billing. They have to report traffic back to the customer. The customers who are going to be using the CDN service need to know what those are so they can actually optimize and take advantage of better ad serving, better monetization. So they need to know all the detailed reports. And so the CDN provider will have to give you reporting. So what are the CDN benefits? Lower reduced latency because the clients are connecting to the local edge site. Better user experience. The page load times are going to be lower. The page is going to be loading faster. Significantly less load on the origin servers. If you think about it, your origin server has the content. It has the original source of content. But now you've taken all the load and sent it to the edge server. And so there is less load that is going to be going onto the origin server. There is better availability, slash dot effect or DDoS effect. Some people can pick up a story about your website and suddenly you're getting a lot of hits. You'll be able to handle that if you actually have edge sites enabled already, even before you become popular. And also some people, they may hate you and so they end up doing a DDoS on your website, and hopefully you can handle that by providing better availability because these edge servers are going to be taking the hit. There's also easy streaming. It's not easy to do streaming. Now you can easily do streaming. You'll see how easy it is to do streaming with a CDN service. Also, you're going to have lower bandwidth costs because you're going to be serving the content locally. You don't have to incur the cost of bandwidth. For example, if somebody is going to be coming from Tokyo to visit your website in Ashburn, that is going to be much more expensive than serving the content locally from Tokyo itself. Web applications in CDN. So how can web applications benefit? How can they use the CDN? Well, the basic idea is that you build your web applications in the normal way. And then you think about optimization. And for optimization, you identify what is static. And don't forget, I mentioned to you that static does not mean just images and style sheets and videos and PDF documents and static HTML pages. Static could also mean dynamic content, which is a cacheable content. You take these static content and put it as objects in CDN. In CDN terminology, they call them objects. And each object has a unique reference key, which is really the URL. So you put these content in the CDNs, and then you refer to these objects using the CDN URLs. The CDNs themselves will give you a URL to represent these contents. Either you can use the CDN URLs or you can use custom CNAME, custom domain URLs. And then finally, you update your web page to use these new URLs, and then you deploy. And once the users start accessing your applications, they're actually going to be going to CDNs to get all these different images and videos and PDF documents. Various CDN providers in the marketplace. Akamai Networks, the biggest player. You got Limelight Networks, Mirror Image, Edgecast, which is now a division of Verizon, CD Networks, and then also Amazon CloudFront. Amazon has a service called CloudFront Service that is a CDN service. So in summary, in terms of internet and CDN background, applications are becoming more and more rich web applications. There is also increase in users all over the world, contents, and devices. We needed a solution to make the internet web platform perform and scale. We saw that original work was done by Dr. Tom Layton and Daniel Lewin at Akamai, who invented the CDN concept. So what is CDN? CDN is really a network of servers for content distribution. The big idea is to keep cache content close to the end user. In terms of the architecture, we have something called content distribution, which is really the art of moving the content from the origin server into the edge servers. There is request routing. Request routing is how the users get routed to the closest edge server. And there is also the accessing of the content, how the CDN caches access the content from the origin and the different cache behaviors that they exhibit. We talked about the caching behavior and the cacheable content. And then there is also the content delivery, which is how the CDN actually serves the content. This is the form of web servers that support HTTP, HTTPS, custom domains in order for them to serve the content on behalf of you. We also redefined what static content is. We said static content is really cacheable content. And finally, we said that a CDN has to do a lot of accounting so that they can give these accounting logs to you for you to incorporate these reports back into your web analytics so you can see what web pages are popular and how to monetize your websites.